Hi, this video continues our presentation of a C++ implementation of a doubly linked list. The previous video went over some private helper functions. Now we're going to use those to make the public operations that the client of our class can use. So first let's look at how we would declare the data types for the doubly linked list. This would be a template class called DLL_list. And the private data members are simply a shared pointer to the dummy node. Remember that in a doubly linked list, we only need that one pointer to the dummy node, and a size t size to keep track of the size of the list. The default constructor needs to initialize a valid empty list. So here we use the initialization, and we set that dummy pointer is a new shared pointer, and we have the same kind of catch-22 situation we had with singly linked list, where the dummy node needs to point to itself, and we don't know the dummy node's address until we finish allocating the dummy node, so we can't construct the dummy to point to itself all at once. What we have to do is here allocate a node for the dummy node, and its next and prev are uninitialized for the moment, and then we immediately initialize them after allocating the node object. So the constructor to DL node here sets the next and the prev pointers to null, which is not valid, but it's just a very temporary thing until the next line of code executes. And we initialize size to 0, of course. Then the body of the constructor does what I just said. We say dummies previous is set to dummy and dummy set next to dummy. That creates the circular links in the sketch that need to be there so that we have a proper circular doubly linked list. The size accessor in the bottom here is straightforward. It just returns the size data member. Okay, now let's move on to operations that deal with the front and the back. So the front accessor is supposed to return the element at the front of the linked list, and we have a exception check. If size is 0, we throw an exception, because if the list is empty, there is no such thing as a front. But otherwise, we need to navigate to the first node. Remember that the first node is always dummies next. So dummy is a pointer to the dummy node. Dummy next is a pointer to the first node in the list, dummy next. And then element is the accessor that gets the element out of that node. Back is basically the same thing, exception check, and then the last node is always dummies previous. So back is dummy previous element. PushFront and PushBack just use that add node before operation that we worked on creating in the previous video. So remember, we have this add node before function. It takes a pointer to a node, and then we add a new node before that pointed to node with the given element. So in order to push to the front, okay, front needs to be before dummies next, because dummy next is the first node, and we want to put a new node before what's currently the first node. Add node before handles that. And pushback is a similar situation. We can use add node before to do all the work, and the new back element should be before the dummy, right before the dummy. So add node before dummy x gets that done. PopFront and PopBack also make good reuse of that remove node function that we implemented in the previous video. Remember, remove node is given a pointer to a node, and remove node takes that node out and makes sure that the list obeys all its invariants. Also, remove node checks for an empty list. So if the list is empty, then remove node throws an exception. So I didn't need to redo that work in PopFront and PopBack. So to pop the front, you need to remove dummies next, because once again, dummies next is the first node, and then PopBack removes dummies previous. Dummies previous is the last node. Okay, there's two other operations: get the element at a given index and set the element at a given index. In order to do that, we're going to have to skip nodes. There's no way around that. So remember that with singly linked list, we had this private member function called skip, where you give it an index, and it starts at the beginning and works its way to the ith node with a for loop and returns a pointer to that node. So we're going to use the exact same strategy. It takes linear time because of that for loop that in the worst case goes all the way to the end of the list. So get at index I, this is basically the same code as for singly linked list. We say if I is out of range, we throw an exception. Otherwise, we skip to index I and return the element there. And similarly, set is given an index and a value, and we have an exception check. We skip to the node that contains that index and then set the element in that node. Okay, here's the analysis of all these operations. So everything here is constant time except for get and set by index. So the default constructor is constant time, no looping. Size is an accessor that takes constant time. Front, back, just follow one or two pointers, so they're constant time. PushFront and PushBack call that add node before, which took constant time, so therefore they're constant. PopFront and PopBack also call remove node, and remove node is constant time. Importantly, PopBack is now constant time. That was one of the major goals of doubly linked list. Finally, get by index and set by index are linear time. There's really no way around that with a linked list because we have to skip nodes.